And I think we're live. Okay, welcome. Today we're going to do day 11 of Advent of Code. Yesterday was horrible. Today, let's hope it's not going to be as bad as the previous one. Day 11, Cosmic Expansion. You continue following the signs for hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. Doesn't know anything about the missing machine parts. He's only visiting this for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Maybe you can help him with the analysis to speed things up. The researcher has collated a bunch of data and compiled the data into a single giant image. Your puzzle input. The image includes empty space, which are dots and galaxies, hash signs. For example, dots and hashes. Okay. The researcher is trying to figure out the sum of the lengths of all of the shortest paths between every pair of galaxies. What? Oh, shit. The researcher is trying to figure out the shortest path between every pair of galaxies. However, there's a catch. The universe expands in the time it took the light from those galaxies to reach the observatory due to something involving gravitational effects. Only some space expands. In fact, the result is that any rows or columns that contain no galaxies should all actually be twice as big. Okay, so in the above example, 3 columns, okay, contain no galaxies. Every galaxy a unique number, okay. And in these 9 galaxies, there are 36 pairs. Only count each pair once in order within the pair doesn't matter. Okay. For each pair, find the shortest path between 2 galaxies using only 2 steps that move up, down, left, or right. Exactly 1 dot or galaxy at a time. Okay, so exactly 1 slot. So the shortest path between. Okay, so is this like L1 distance basically? I think that's L1 distance. Just very badly made, or I'm not sure. Would that be considered like an L1 distance? Let's count it up just to be sure. So we should have exactly 1 step. Okay, so we should make sure if it's just L1 distance, then we should be very fine, and if it's not, then we need to worry a little bit. Okay, sorry. Back to the thing. Okay, so we got the pairs, although doesn't matter. For each pair, find the shortest path between 2 galaxies using only steps that move up, down, left, right. Okay. For example, this is the shortest path. Here's one of the shortest paths between galaxies 5 and 9. This path has a length of 9 because it takes a minimum of 9 steps to get from galaxy 5 to galaxy 9. The 8 locations marked plus the step onto galaxy 9 itself. Just to be sure, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so yeah, that's L1 distance for us. That's very nice. Hi there, viewers. You're welcome to chat, and I will try to notice what you write and actually respond to that. The path length of 9, yeah, as we said, it's basically the distance plus each next step. Yeah, between galaxy 1 and 7, 15, galaxy 3 and 6, it's 17, galaxy 8 and 9, it's 5. In this example, after expanding the universe, the sum of the shortest paths between all 36 pairs of galaxies is 374. Expand the universe, find the length of shortest path between every pair of galaxies. What is the sum of these lengths? Okay, so let's do that. We start, as usual, with duplicating the previous day. Nothing fancy about that. Adding our enum here. Adding our function call to day 11. And because we haven't attached day 11, we should attach it. Oh, we haven't attached even day 10. Interesting. Do we not have day 10? Oh, we already have day 10. I see. It was just sorted badly. Okay, everything is okay. And now we can clear out anything that we aren't happy with, which is basically this thing. Yeah, so part 1 and 2, we still don't know what they are. Not at this point, at least. And everything else can basically go. Oh my god, that's a lot of code. And within our test, we clear everything up as well. Just need the test part 1 and test part 2. So let's do that. Let's paste our inputs. So firstly, we know that we need to learn how to expand things. So let's try to expand this galaxy. So we know that our input is going to be something like so, and we do need to like test, like do the expansion thing. So let's do that. First of all, we can create like the part 1 and part 2 things, just so we'll have something. Yeah, seems to be legit. And so this is like a nice little scaffold now. And let's test expand. So this is our expansion now. So we need a test function, test, not pass, but test expand universe. Expand universe. That is going to receive well, this not this. This is the expected. So just a minute. So this is our initial input. And we let expected be this string, which is the expand one. So we should say expand universe on input, and we expect it to be well expected. So up to some like unwrapping, I guess. So yeah, let's do something like that. And let's create our expand universe. So this is going to be expand every empty empty row and column in the universe. Function expand universe that is going to consume some input string, and that's going to return an iResult of well the consumed input, which is our refster, and well another string. That's actually going to be a new string. So that's going to be literally an allocated string. I think that's the first. That's a first. And it's unhappy because we are not returning anything, but that's okay because we will now do that. So actually, you know what? We might want to just pass that into an actual vector and then find empty rows and columns in that vector. Would that be nicer? I mean, there's no need for us to actually count up missing to actually do this allocation, because all we need to know is basically just how to multiply the thing. So you know what? Instead of actually expanding the universe like so, I mean, it's very nice. It's a very nice test. but we could also like expand like symbolically. So you know what? Let's not start with that. Let's actually pass this into, well, a coordinate board, or I mean, just a hash map. So type universe. That is going to be a hash map of I size to I size, which are the coordinates that we've got. And all we've got, oh, it's actually a hash set even. It's not even hash set. And how do we make that order invariant? Let's talk about that. Can we do that? So this is our universe. It's just a hash set of these coordinates. So let's actually call that galaxy. That's just going to be, so type galaxy. We've got just a tuple of I sizes. And that's just going to be a hash set of galaxies. Or even actually a vector, because, well, universe is, we scan it exactly once. Then we need to transform things, but that's okay. So how are we going to do that? We are going to basically, we're not going to test the expand universe yet because there's no universe to expand. So that is going to be a to-do. By the way, this should probably be an iResult thing, and that's good. All of this is crap. This is not something that we actually need for now. And part 2 as well, we don't know what we are planning to do here, so let's just leave a big ass to do. And now we've got that sorted, let's try to parse the universe. So fn universe. That is going to receive a string input and give us a string of a universe. So many one galaxy, that's almost good. But we do need to walk this. Actually, you know what? Actually, I think none is not actually a good thing here. I think we can literally do that with just, well, doing like honest to God parsing. Yeah, that one, exactly. So, oh, yeah, should have been U size, not I size. That is correct. Yeah, so we've got our X and Y's, and this is our universe. Do we want to test that out? I think we do. So function, well, not class universe, sorry, test, fn, test universe. Let's just have a very small universe. So this is the one. That's too big. So dot dot pound, I think that's good enough. And we do need to say expected equals, if Copilot is bullshitting or not, that's going to be 1, 0 and 2, 1. Yeah, seems legit. And expected universe, let's test it out. That's going to compile. Oh, there's a lot of compiling. What is going on? And our test is passing. Okay, that's very nice. Okay, so we've got our universe. We should think about whether we want to expand it now or later. Let's figure out if we can understand which are the empty rows and columns, and then like we should +1 everything that's above that. I think there might be something nice in actually doing this transformation. So let's just add, okay, so could be nicer to basically, okay, so I think we want to expand the universe like actually like in string form. So how would we do that? We should have a function which is called expand universe. That is going to first of all get an input string and return not the universe, but Copilot. You are so. Oh, actually, we could do that a lot nicer with actually just iterating input lines, enumerate, and flat map, and then iter stars enumerate. Yeah, I think that would be nicer. Some XY, yeah. Why filter map? Oh, yeah, we do want to filter map. That's actually correct. Okay, so yeah, so we've got XY. I think that's nicer. Let's actually test if we haven't broken anything. And it says expected struct usage found unit. Why is that? We are flat mapping everything. We are collecting. Do we need to do anything else? Oh, it's complaining about the mismatch types. So to do this one, let's compile that. It says that y is borrowed and may outlive its borrowed value. So we do want to move and move that. Okay, so we have now constructed a universe from string. That's very nice. Now let's think about expanding the universe, and then we could start thinking about actual distances and algorithmics around that. So how would we want to expand the universe? So we want to see how do we do that? We can iterate over all of the galaxies, and we can iterate over all of the rows. Let's think about that. How would we want to do that? So we want to keep track of all of the columns that indices that we've seen and all of the rows indices that we've seen. If we've got both of these, all we need to do is basically add another column and or row in each part of the matrix. Like we just push a thing in between them. Okay, so I think we can do that. Let mute. Oh, we could actually just do that. Okay, so let rows be that's going to be a hash set of usize, and that is going to be row so rows with galaxies. You know what? We could literally just okay, let universe be this thing. Now, so let rows with galaxies, that's going to be a hash set of, yeah, and colors with galaxies. So this is the basically both of these on the same thing. We could like do that more optimally with actually just keeping track of whatever, but let's just not think about efficiency, but just moving fast. So we've got that. We want minimum x and minimum max x, yeah. All of these are somewhat correct. So expanded universe. Do we want to expand that logically? I'm gonna flow with Copilot for a minute. For y and thing, if universe does not contain xy, then universe push. That's not thing. No. So what I thought is actually just expanding, like creating a new input and then creating a new universe from that. So that way we don't need to think about anything fancy. So let mute new input, string new. Can we clone? Oh, actually input as string. I think that's going to be input as stir. toString. Okay, so new input. Now, is there like a nice way to basically just do this? Like insert in the middle? Do we want maybe what I thought is basically doing like a single pass like that, and every time like inserting one more and just pushing everything. But if we do that, we could literally just do that for all of the for the universe without actually doing anything. So let's think about that. So we've got our hash set, but we don't really want that as a hash set. What we want is a unique vector which is sorted. So how would we actually do that? Is there like a unique thing? Ooh, unique. Sorted. Collect. And this is going to be a vec. And it says that no method name on iter map the current scope. Is there like a unique thing? Let's think about. Let's look at that. So we've got so into iter unique by length. Interesting. So would and is there like a unique without like anything fancy? Yeah. So into iter tools. Okay. So so that's an iter tools thing. We could import iter tools. Okay, that's very good. So I mean, come on, I'm just gonna do collect into a set and then just why bother? Okay, so we've got our collect into hash set of something, and we don't care about that. And then once we collected that, we could continue this iteration. And now we want to say sorted collect into a vector. So that's going to be a vec of usize. And it is claiming that no method sorted on iter usize. Interesting. So do we need to collect that into something else before that, or we can we collect and then add the sorted thing? So dot. Oh my god, so much crap. No cloned, not yet. Iter sorted. I know this is terrible. I'm gonna try to clean this up in a minute. So here we've got vec of usize. This is still unhappy, and it is claiming that no method sorted for struct slice iter found in the current scope. Oh, it might be because it's a reference. If we add the cloned thing, it still does not know what to do. So that's not going to happen. So we've got map into wise. We could say unique here. Then just directly collect into vec. Would that just work? Maybe. And it still claims that unique is not a thing. So don't mind that then. Yeah, let's just do collect into directly into a set. Then just deal with that in a minute. So we've got our set. We can delete the type hint here. Type hint, the actual type. And that's a set of view sizes, and we've got the same thing here. And let's just have our unique sorted thing. That's going to receive some kind of container and input C. That's going to let mute into iter collect. What? Okay, so can we just say unique collect? Or would this still again not work? Use iter tools into iter unique. So do we not need to like do the collect thing? Can we return that just directly? Not this one, unique. So it needs to have, we've got a vector of data into iter unique should be equal to the thing. How is that not working? Or is it, maybe it's just, is it maybe just my thing? So let's just do that here. We've got no dot input, just into iter unique, this thing, expected hash set found unique map thing, and we can say dot collect. And let's actually, yeah, we don't need to say, oh, maybe we do. We could say vec of thing. And let's actually see if this compiles. So if this compiles, then that means everything should be just fine. So let's just have it. Yeah, we should say expand universe on input. And let's just run this test. We're not going to run anything, but I just want to see like what the compiler actually says. Okay, so this compiles. It's just my IDE is complaining, not the actual compiler. So if that is the case, then we can say also unique sorted. And that would be the most nice thing, because that means we could, yeah, let's Copilot do this, duplicate everything, just use the X coordinate instead of the Y coordinate. And now that we've got that, let's see if we needed to do something. Like what would we actually want to do? So we've got our universe and we would like to expand it. So how would we iterate on that? We would like to do something in the lines of basically we would like to first of all, let's we want to like basically plus everything to the right of something. To how would I want to do this? Let's actually just write a small test and then let's try to attack it very slowly. So let's pretend this is again our test. And what would be our expansion thing? Firstly, let's actually try to do this. And in order for things to actually work, we need to strip the input out of, so we need to strip \n and wrap or input. Yeah. then strip suffix, grep or. No need to string. Okay, so we've got basic like string handling. I just want to like drop the beginning and ending line thing, the like trailing and beginning lines. So I've got that. And now how would the expanded universe of this look like? This would look like so. It would look like this row stays same. I mean, it gets expanded. Then we've got our galaxy, we've got a dot, we've got our galaxy, we've got our dot. So this is basically our expansion. Quite lame, I'd say. Let's add another thing like so, and that would leave us with the same thing here, and also another row. So this is a nice expansion thing that would actually push us to implementing something. So now that we've got that, let's actually write our assertion. So we've got this thing, yeah, sure, okay. And how would we implement that? Max row and call, max call, sure. So we could say for this to this, we will iterate over everything. Yeah, that's bad. That's not gonna work. We want to keep track on two things, which is like basically the difference. Like, okay, so let mute x increment and y increment, and that's going to be a use size and use size. And oh, actually, we know that first of all, okay, we know the line length, so we know exactly how does a thing look. How does that look? So let's actually collect that into just a vec of vectors. Let's just do this. So we've got let vectorized the input. So that's going to be lines map, not line. Yeah, no. Just lines. And then we will just yeah, we map that into chars. We don't need to collect anything. And then we just collect that into a vec of vectors. Vec of char. So this is our lines. This basically means that, oh, do we need to collect that? We do. Okay, so we've got vec of chars. This is our vectorized thing. We know how does, so just, so row is just going to be basically repeat. Can we repeat things easily? Repeat dot. Just input lines first dot let row length. I just want to have like something to push. So that's going to be input lines next unwrap length. Okay, sure, whatever. And call length, same thing, count. Yeah, seems legit up until the fact that we need to strip the input. So let's just strip it directly here. Or you know what? Let's just not deal with that at all. That's way better to just not deal with things. So we've got our input, we've got our row length, we've got our column length, column length. So what we would want to do is expand the universe. We need let empty row. That's going to be repeat thing. Take row length. Collect string. Yeah, and empty column. That's very nice. So we've got our string, we've got our vector. Oh, it's actually collected into a vector of dots. So that's going to be not collect to thing, but collect into, please be a char, vector of char. That's very nice. So we've got our vectorized universe. New universe is going to be for 0 and column length, y and column length. So I want to basically just, yeah, so now we don't actually even need like the whole input here. We haven't used it. That is just terrible code, Copilot. So we can't iter on everything, and we need to mutate that. So let's just mutate that, just like that. Oh, but we do need like the empty things because we need to know like what are the actual things that we want to insert. Oh, well, we actually know what the target length of everything is because we can count it up. So that's actually not correct because that needs to be the row length plus not to know the amount of empty call. Okay, so sorry. Let empty call count. That's going to be call length minus the columns with galaxies. Yeah. Oh, so we can just plus that. Okay, so that is going to be our new size, basically. That's on new dimensions. So we've got an empty row to push into the vector or insert, basically, like in some indices. And how would we insert that? We could insert that back to front, and that means that our vector always keeps growing, and that would actually work. So can we just do that? So let's try. We've got, let's start with rows. So for rows, iter dot reverse, because we want to go back to front. Vector insert on y. What does it say? It says return function instead of unit. That's okay. To do. So we've got this insertion is going to be every time empty row clone. Yeah, that's very nice. So for each row, we are basically inserting on the index in reverse, and also on the columns. So we could say exactly that. So for each, we will do this. Then we could join everything. Or we could actually just collect that. Would that be a universe also? It would, but vector of chars. So instead of that, I would prefer to join that actually back into a string. So let expanded stir, just so everything would be basically, yeah, I think that's very nice. Okay, so we are collecting into strings, then we're joining everything by new lines, and then we could return universe on expanded stir. And it says that expected thing, found thing. So that's a universe. Why is it unhappy? Expected a function, but found universe. Oh, I see. Sorry, that's going to be small universe. And then this is it. And now we've got that. How come we haven't inserted empty columns? We should have had this. No. Empty call dot clone. And why is it unhappy? Yeah, because it should have been expected char found vec of char. Why is that? So for vectorized, oh, that's just not correct. So we should just say so for each row. Oh, I see why actually Copilot did that. That is actually correct, but that is a bit terrible. By the way, the inserting in reverse is like actually important because that would actually do the thing that we expect it to. This one, we could have done that also. Like this is quite terrible, like inserting for every row, but I guess like that's the way to do it when you're talking about like vectors. So yeah, that's going to be terrible like in terms of memory performance, but that's actually going to work. So yeah, I think that should be this thing. So expanded universe gives us this thing, and then that means that expanded universe doesn't actually return the string, it returns, oh, because universe is tested, we could literally do this. Expanded universe is the universe of the expected. Yeah. And if that compiles and tests, that would be amazing, but of course it doesn't. So let's look at that. We've got expand universe on the input, which is a thing. And then our left and right assertions are just incorrect. So firstly, let's dbg our standard string. And now that we've got that, let's look at that. It is way too expanded. So, ooh, I see. We should have done that in the opposite order, I think. Is that correct? No, it's still not correct. So, let's look at that very, very closely. We've got let firstly, what we expect here to see exactly one empty row and one empty column. So let's actually dbg that, and so these are rows with galaxies and without galaxies. Oh, we are duplicating on the wrong thing, so we need to filter out by the actual range. So this is actually not the right one. So you would like to basically do this. So we could save that into a hash set, and we don't need to do any sort and unique here because we are going to iterate sort in a sorted way. So we've got hash set of usize and hash set of usize, calls with galaxies and rows with galaxies. So these are a little bit more clean and nice. Now we want to do this thing, which is we want to say 0 to, what is it? So we do need like our minimum x and maximum. So let max x be this thing, and let max y be this thing. That's nicer. And we could iterate directly on max max x through 0 because we could. Is that's incorrect? Okay, so let's just do that. Then okay, so max x. It's a reverse, so we don't need to iterate on that because it's already an iterator. But we do want to filter on our predicate, which is for columns. We want to say x, and we want to say not contains on x. So yeah, we want to say we want on each of these x's, we want to flip any index that's not contained on the thing. We want to do this push. And why is it unhappy? Because we just need to say insert like so. Is that a thing? I should hope this works. I'm not sure. We might need to like say move or something. And then we could do the same pattern for y. So let's just do that. And let Copilot do the thing where it copies everything and hopefully doesn't fuck everything up. So we say 0 to y, reverse, filter on rows with galaxies, contains thing, so nothing, anything that's not in our rows with galaxies. So these are all the empty indices basically. And then for each one of them, we are going to say insert an empty row. I think that is okay. Let's try to run that. And our tests are actually passing. Wow. So that means that we can move forward with actually collecting pairs. So let's do that. So we've got our universe. We would like to test out not only the universe, but also we'd like to fn test in distance. So this should be a distance of well, that expected that's going to be a distance of 3 because this is how things are. Okay, so we should say let universe be this thing, and then assert that in distance between. We should like okay, this should be like the min distance map basically of everything. So let distance pairs should be interesting. Is the a Cartesian product thing? Oh my god. What the hell? That's so nice. Damn. So first of all, that's exactly an L1 distance. Let's actually verify this is actually correct. So this is going to be 5 minus 3, minus 2. So, sorry, 4 minus 1. So that's going to be exactly 3. Yeah. Okay, this is our basically L1 distance. Okay. So is this actually a thing? So what is our expected? That's actually, yeah. So our expected needs to be a deck of 3. And that would need to be expected. And we don't need to apply this anything onto that. And let's try to run that. If that is just working, then like I would be amazed. But no implementation from i30 to i32 to integer. Why is that? Because this is map. So these we need to wait. So it's a minus b, a minus b. Okay, so we need an L1 formula. So let's just call that L1, and let's just have Fn L1. That's going to be y absolute plus, yeah, that's okay. And that is a u size and a u size. Oh, that needs to be an I size because, well, could be signed size. So these are just going to be, yeah, thing and b minus b thing and a1 b1. And why is it unhappy? Because it says found I size, wanted u size. So as I size and as I size, yeah, sure. So we've got L1 of A and X and Y. We could have like passed the actual pairs. That would have been nicer. So let's actually do that. So this is going to be an L1 of A comma B. Then we should pass that as a galaxy. Yeah, that's an actual thing. So that's going to be a U size because everything is positive, but we are going to return a0 is I size, abs as U size. We don't need abs, doesn't need casting. I should hope. Apparently it does. Why does abs need well, okay. So let's just cast that later. So we could say this, then just wrap this whole expression with an as size. Okay, so we've got an L1 between each galaxy. So that is just going to be mat L1. And we can run that, and that should give us thing, and it says iterate map that takes a single two tuple argument. Oh, I see. So yeah, I'm okay with that. Giving it like a two tuple argument. Is that possible? Yeah, so AB is going to be a two tuple argument. Then let AB, whatever. Let's recompile that. And it says that left 2. Okay, so this is the point. This is the spot where we need to dedupe. So how do we dedupe that easily? We need to say not A not equals B, but also we need to dedupe duplicate pairs. So did you buy not only so Cartesian product, that's the actual thing. Um, that actually seems to be okay. So what the fuck? We've got iter on the per. Oh, is that? It's not any. It's not pairs yet. So we've got iter on the Cartesian product of the universe. Do we need to do that? Oh, I see. It's iterating on itself. By the way, it's just is there like all the pairs or something? Um. Hmm. It's basically okay. So it's a Cartesian product on itself right now, and that's why we've got everything duplicate. We if we want like all the pairs, we would need to do something else. So that's going to be Rust iter tools pairs structs. Interesting. So what are combinations? Um, so I want all the two length combinations. Yeah, that's actually better. So combinations sub 2. Would that be better? So we've got this thing. That's going to be a vector of galaxy global. Interesting. So that is going to be AB. That's a vec of two galaxies. I see. So first of all, let's actually map that back into pairs. So we should say, yeah, AB, vec AB. And then everything is A, comma B. That's nicer. And can we like take ownership on that? Let's try now on that. We'll complain about something, which is required something, blah, 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 blah. So this filter doesn't really matter anymore because we don't have any repetitions at this point. We've got combinations K, and we can pass that as an L1. So dot we do actually, yeah, I want to map that into a tuple. So that is going to maybe work. That's going to compile. Oh, yes. Okay, and we've got another thing, which is let's actually add another floor, another row. And let's add dot, 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 dot. That shouldn't change anything. Then we should have, let's have another pound here at the start, and we've got dot, dot, dot. That should be 5 dots. Okay, so what are the distances that we should be seeing? We should see 3. We should see let's look at that. We've got what's the distance? Oh, it's hard to reason about that like so. So let's actually reason about that. Actually, in this way. Okay, so so we've got a distance of 1, 2, 3, 1, 2, 3, and we've got 1, 2, 3, 4, 5, 6. So 3, 3, 6. And just to be sure this is actually going to work, we should say something like sorted. So iter sorted. And that would say that we cannot we need to do something. Distance pairs. So you know what? Let's actually sort them right here, just because we can. And that would give us like the advantage of like comparing everything. And we've got 3, 3, 6. That's very nice. Okay, so this is the min distance pairs. Let's back that into a function which basically accepts a vec of type universe and returns a usize, and that's going to be min distance pairs. Okay. Now that we've got that, we could actually go for our actual assertion, which is going to be, we go back to this one, we should have 36 pairs and they all sum up into 374. So this is our input universe, and it should sum up to this one. And let's go to run part one. That is going to accept an input string. That's going to be an input string, and we've got let universe expand universe. That doesn't need to be mutable at all. All we need to say is min distance pairs. Why is that not working? Min distance pairs. Oh, it's within the testing scope. I should graduate that into this area. So we've got min distance pairs. And all we should do on these pairs is sum them up. So let's do that. So we should return that directly. So we say min distance pairs. Okay, on min distance pairs dot sum. Iter sum into string. So result string, yeah, sure, whatever. It's already a string, so there's no need to do the toString here, but we could actually just have our usize right here. And that's our summation. So let's run part one. And would that sum up? And it says that we need to pass an argument, and it is unwrong. Oh my God, it actually worked. Okay, so let's run that on the actual input. And let's paste that input right into the thing. Is there argument destructuring on the L1 function, or do you need to do it one separate time? On a separate line? Is that like an old question, or how did I miss I don't know, like there's no timestamps on the chat. If that question is still relevant, then ask it once more. We have like done the AV thing. We are doing the structuring like so. There's probably a way to maybe destructure things like in the function argument, but I'm not sure. Ask when you're excited. Oh, I see. So yeah. As you said, as you've seen, we did the destructuring like in line. So where were we? We were at copying the inputs. So yeah, let's duplicate that, call that day 11, add our gigantic universe. Hope things don't explode completely, and let's run that through our machine. So we should say D11 fly run, and that all should be not linear time, but basically we're not like doing anything like quadratic or cube or anything like that. We're just we're doing a few very deterministic amount of passes. So we've got our part one thing, and we should submit that, and we get the gold star. Onwards to part two. By the way, how long did that take? That took 1 hour. That's more time than I thought. So the galaxies are much older, thus much farther apart. than the researcher initially estimated. Now, instead of expansion, like you did, make each row, empty row and column, 1 million times larger. 1 million times larger. That is, each empty row should be replaced with. Okay, so now we cannot like allocate. Or we could, but that would expand our like this would be crazily hard. Okay, so we should try to, instead of like doing that manually by keeping track of this grid, we should like actually try to multiply things by a number. But we should like add numbers to things, basically. That's very, very, very unnice. There's like a in the example above, if each empty row and column were merely 10 times larger, the sum of the shortest paths between every pair of galaxies would be 1030. If each would be merely 100 times larger, it would be 8000, blah, 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 blah. What is the sum of these lengths now? Damn. Fuck. So back to expanding the universe, I guess. So this expansion now needs a factor. So that's going to be a factor of 2. 2? Yeah, twice. So let's give us an expansion factor. So expansion factor. That's going to be an either 2, which is enough. And it could be by default 1. Are there no default arguments for Rust? Okay, currently not. So whatever. So what is the expansion factor then? So we've got our rows, we've got our empty indices. And instead of doing this insertion, we know what is the actual transformation that we want to do to the indices. So let's actually think about it in terms of like transforming the like the actual values. So instead of actually keeping track of, so we've got our rows with galaxies, we've got our rows without galaxies. So let's just have them. So let rows without galaxies. That's going to be filter collect vector. Okay, and let's just, for good measure, let's sort them. And that is going to be very important. So we've got that, and we've got columns. And let columns without galaxies. So now that we've got that, how would we actually want to do this? We don't want to do any allocations. We don't want to do any string processing. All we want to say is what is the plus plus amount basically for each gap. So let's think about that. You know what? We could actually. Okay, so I've got maybe another idea, which is to say we've got our 0 to max x. We could iterate on that, and let's try to scan that. I think scan is the right one, and then the scan is going to be plus plus. Yeah, okay, because we want to keep track of everything, of all the intermediate values. So we've got our accumulator and our actual index. Okay, so that's going to be our x index, or just x actually. Okay, so if calls so why is it unhappy? Just because we should say let underscore equals b equal this. Okay, so this is going to be if we have a galaxy in this column, then we want to plus plus by 1 because it's just a regular column. Or we don't need to do anything because we just want, Okay, so we do need that. And then else, we want to say ACC plus equals, if it's not, if it does not contain, it should be plus the expansion factor. Then we should return some accumulator. Okay, so that should be it for this thing, and then we should say, so yeah, these are the expansion. So that's going to be x factors. That's going to be our y factors. Or offsets, actually, maybe that's a better way to offsets. Better way to phrase that. So offsets. We should probably collect that into a vector. So collect, and we should say something like, yeah, vec of I32s. Yeah, that's definitely not enough. Should probably have that as an I size, just to be sure. And then it says that why is it unhappy? Because this one should have been I size. So now this can be okay. So that's going to be an I size then. I don't care about that. So yeah, I think that is yeah, we've got a mutable I size. We're doing that. Let's just fix up our X thing. We've got that, and it's either so expansion factor of 1 would just leave the universe as is. So that's going to be a very good thing to test. And then we've got expansion factor of 2. Expansion offset of 2 is going to be the expansion, the regular expansion, basically. And then expansion of million is an expansion of million. We just need to map that now back into our actual thing. So how would we do that? We can now got x and y offsets, and these are a vector of I sizes. Now, so expanded universe, let expanded universe be small universe, it'll map on this thing. So that is going to be x offsets. So I want, yeah, so these are actual indices. That's okay. And all we want to say is why is it nth blah 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 blah? Like just like so. Why is this unhappy? It says cannot index into value. Oh, we forgot to collect. I see. Okay. So these ones are the thing, and we is this collecting the right one? Why is it unhappy? It says the value of the U size cannot be built from iterator I size. So this one should be actually as U size. It's always positive anyway. So we don't have a negative expansion. So that's actually the thing that we want to do is change this. Where's our offset? So yeah, that's going to be U size. And expansion factor is going to be also U size and U size. Okay. So we've got our X offsets, duplicated code fragment. Oh, that's okay. I don't care about the duplication here. Not at this point, at least. By the way, we could probably do something like no, that's actually nicer. That's actually nice. So now that we've got a linear growing thing of offsets, all we need to say is basically apply this translation table onto our thing, which is this expanded universe. And we could try to basically return that. So let's do that. Comment out all of this crap. So we've got an expanded universe. And we could make some assertions on that. So first of all, let's see. So expansion factor of 2 should be this thing. So that should test and should be okay. And we still have things that won't compile, and that's okay because part 1 has an expansion factor of 2. And let's look at that. It says that it's unhappy. Why is that? So first of all, it says that things are unused, and that's okay. I'm okay with things going unused for now. We've got rows with galaxies. We've got our X offsets and our Y offsets. And for each of these, we want to do something. And these are scanning from 0 to whatever it is. And for each one of these, we would like to... Oh, wait. So should we actually do +1 or +0? Let's try +0. Or as I would call it, just nothing. Then we can invert this if condition. And else nothing, we return the accumulator. And the tests still fail, which means that I'm still wrong. So let's look at the test and see what we've got. So on the left, the expanded universe has got completely wrong things. So that is just blatantly wrong. So first of all, we've scanned and oh shit. First, yeah, invert if nothing here. And now we've got somewhere, which is almost correct, but not quite. So our expansion factor should start as nothing. That's okay. And we can remove the parentheses. Okay. So if our columns do not have that, so is our expansion factor 2? It might be just 1 or 0. Okay, so since it's an increment, okay, so let's try an actual expansion factor of 1. File that, and our tests are working. Okay, that's comforting. So that means that also in part 1, we should say expansion factor of 1. Nice. Let's run that again and see that we've got the same result as we'd expect here. And that part 1 also runs and seems to be okay. And if we run this against the actual big input, we've got the same answer as before. Great. That means we should be able to plug some other things and they might just work. So firstly, let's actually start with something very, very simple before we actually like bring the big guns. So we've got that. We should say, oh, expected. Now let's add, so let's have an expansion factor of 2. So that would be +2. So we've got that, then ... So this is basically plus 2 for everything. So, or wait, is it times or should be replaced with 1 million rows? Interesting. So instead of doing that as interesting, so instead of maybe a summation, we should say, let's think about how would we want to do that? We should say always like I think that should just be okay. Let's try that. Let's think about that. So we've got tests. Sorry, we've got tests. Let's just do that. We've got assertions right here. So we don't need to actually write this down like so. We could say we could add the same thing, but now with different things, with different expansions. So we just need to like refactor things a little bit. So this is our universe. That's okay. We don't care about the universe itself at this point. We've only thing that we've got is basically we should have min distance pairs on universe. So we could just yank that, and in part 2 we should say their input is going to be exactly the same. So, and that should be an anyhow result. Now we could assert that not min distance pairs, but actually the sum on them, sum, iter sum. So yeah, min distance pairs, iter sum. That should be, if the expansion factor is 10, that should be something which is 100, this number. And then if the expansion factor is 100, that should be this thing. And we should say, okay, something. Yeah. Okay. Let's run that. That would obviously fail. And it says that we need to do something. If we say usize here, would that help? No, it still needs to know what we are aiming for. So let's add usize, whatever. Yeah, so these ones are off by a number, which means that we've got still bugs, and this is not what we'd expect. I will try just to be certain. I will try 99 just to be sure that it's not like an off by one thing. And if it's an off by one, but we could just use that as is. Damn. So basically our expansion factor, we could pretend our expansion factor is whatever we want it to be, which is, let's call that 2. And let's call that 10 and 100. And also within our actual assertion code, let's call that part 1. Let's call that 2 as well. And now this needs to be let offset be expansion factor -1. That's it. Now we should say this is our offset. This is our offset. And let's actually run all of the tests, maybe. Can we rerun all of them? Just to be sure everything like checks out, everything's kosher. Yay, everything looks fine. That's very good. So we could like remove all of this crazy commented out code where we did like these allocations. We had to be not lazy. And now let's run that over our actual big input. And that is compiling, running, and we don't have an answer because we have forgotten to obviously run this. So how would we run that? So we should say something like, yeah, part 1 is now this, and part 2 is the same thing. So now input thing, and the factor size is exactly 1 million. And that should run. Should be quite quick. We should just say pass the input. And we've got a big ass number. we're gonna plug that in and pray that we win. Yes. Okay. That was a really fun one. Oh, that was actually nice. Okay. So I'll see you tomorrow then. This one has been actually fun and like not terribly terrible. And it only took 1 hour and 25 minutes end to end. So yeah, I'll see you in the next one, and bye bye for now.